Yo everyone, this is LeetCode 232, implement queue using stacks. I don't particularly like this problem. I don't know if it's because it's trivial or why, but I just don't really like this problem that much, but I'll do it anyways because it's on the Gren 75 list, but we just have to implement a first in, first out queue using two stacks. The queue should have all the normal functions of a, should have all the, support all the functions of a normal queue, such as push, peek, pop, and empty. So yeah, not too difficult. So how we do this with two stacks, um, I kind of did an illustration so I can show you visually. So let's say we have a queue, right? We had one first, then we had two, and then we had three. So we add numbers like this, right? The number we're gonna add goes here, and the numbers that we first add are gonna be on the rightmost side, right? So first in, first out. So using a stack, essentially we're going to maintain that order by maintaining all the numbers in a first in, first out operation like this. So when we pop from the stack, we're getting the first number we put into the stack or into the quote unquote queue, right? So when we want to add a new number, such as let's say 4, what we're going to have to do is we're going to take this stack and we're going to empty it into the second stack like this, right? Then we add the new number 4, and then we empty this stack by popping everything and putting that into the first stack again, and see how we maintain our first in, first out kind of fashion using a stack. And yeah, that's how we use a two stack. One stack basically just keeps all the numbers in the proper order, meaning first in, first out. The second stack we only use when we want to basically append a new number to the queue. We have to empty it like this and then put it back in, right? So that we can maintain our first in, first out kind of ordering, because that's important. Okay, I don't think that's too difficult conceptually. Should make sense. So we're going to start off by obviously creating our stacks, which are just lists in Python. So now we're going to do the push thing, which is what I just showed you. So we're going to say while the first stack has anything in it, we are going to add to the second stack by pushing or by popping from the first stack. Okay. Now, after we pop everything from the first stack and append it to the second stack, that's when we actually want to add our the actual number or the actual value we're going to add to our queue, our new number. Okay. So add that to the second stack. Now we take everything from the second stack and pop it into the first stack. Okay. So we're gonna say self.s1.append self.s2.pop. Okay. Now when we want to pop something, the ordering is already in a first in, first out fashion, right? That's why we're doing things like this when we're pushing. So everything should already be in a first in, first out fashion. So we can just pop and we'll get the number. I'm saying queue, but really we're using stacks, but I'm just saying conceptually this is how our queue works, is when we want to get the first item out from our queue, we're just popping from the stack for that to happen. Yeah, now peek is essentially like we're popping, but I said we don't actually want to pop. We just want to see what's at the top of the stack. Also, the reason we do -1, right, is because we add the 4, then we add the 3, then we add the 2, and then we add the 1 back. See how we maintain our first in, first out ordering here? But since this is the last number that's added to the stack, that's why we want to get whatever is the last element of the list. Conceptually, I'm drawing the stack in a vertical fashion like this, but like technically our list looks something like this, right? It looks like this, right? So that's why we want to do return self dot s1 and then -1, so we can get whatever's the last element of the list, since that's how our ordering looks like in our list. So yeah. Now to check if our stack, or rather a queue, is empty. Well, to check if our queue is empty, we need to check if our stack is empty, right? If there's nothing in the stack, we're going to return true, which means, so technically when we call this function empty, this function empty is going to check, is there nothing in the stack? If there's nothing in the stack, it's going to return true, which means it's empty, okay? So return not self dot s1, right? Return, it's basically asking, is there nothing in the first stack? And return true or false. Okay? Pretty simple. Yeah. I tried explaining everything as best I could. I think part of the reason I don't like this problem is it's annoying to explain, because technically I'm talking about, oh, this is what the queue looks like, but we're not actually using a queue, we're using a stack to implement the queue. So when I refer to the queue, I'm technically referring to the stack in this particular problem. So it's just kind of annoying to explain this problem. So that's probably one of the bigger reasons I don't like this problem. But yeah, I tried showing that illustration here, so I hope it's a little bit clearer. But yeah, problem isn't really too bad. It's just annoying to explain everything for this particular problem. So yeah, I hope this helped, and I'll see you later.